Another task that you might have to execute on a certification exam is calculating the total resistance in a circuit where there are multiple resistors. And I'd almost bet money that you will see a problem where there's a circuit diagram like what we have over here. Something similar to this. It may even be a little more complicated than what we have here, but there will be a problem with the circuit diagram. And you'll probably have to calculate the total resistance based upon the information in the circuit diagram. This circuit diagram tells us that we've got a 24 volt circuit when we've got three resistors, 15 ohm, a 10 ohm, and another 15 ohm resistor. Now resistors could be light fixtures, switches, receptacles where we tap into the power. That's what we mean when we talk about resistors in a circuit. Again, there could be multiple resistors, more than three. In this example, we have three. There could be 6 or 7. I've seen some practice problems where there are, and I've got some practice problems. If you want to look at them, just bring me a flash drive. I'll give you a copy of them, where there are multiple resistors, and it's much more complex than this. But this is what you're likely to see in the exam, something like this, something that's relatively simple. Another thing about problems where you're going to see this, they're going to be multiple part problems. You're not going to have a situation where you're just calculating the resistance, the total resistance in a circuit, but that's going to be part of a more complex problem that has multiple parts. And that's what we're working toward with these tutorials, is that kind of multiple part, multiple component problem. This is just a step in that direction. For this tutorial, all I'm going to do is show you how to calculate the total resistance in a circuit like this. And we will calculate that total resistance with this formula. Again, it looks intimidating, but it's really not. It's not difficult at all. We start with this formula, and all we're going to do is enter the numbers in this formula and then do the simple calculations that are involved. Again, I've done this in the other videos, but let me say something about the procedure that I use for these types of problems. I always start with the formula, then I work it out step by step, iteration by iteration, until I get to the very end. By the time I'm done with this, I'll have 7 or 8 different iterations to get to the total resistance. Some of you might be tempted to go from step 1 to step 8 and work around all the middle steps. Be careful with that strategy. If you try to skip steps, skip iterations, you're more likely to make a mistake. This is very systematic, very deliberate, and it's not as slow as it appears. If I was just working through this problem without taking the time to try to explain what I'm doing, 30 seconds is all it would take to do the calculations, because mathematics are really simple. Speaking of mathematics, let me go ahead and make sure I have my calculator ready to go. Yep, there it is. Go ahead and get it out of the way. But first step, write down your formula. The next step, you're going to plug in the resistance values, or the resistance values for the different resistors. Resistor 1 is 15 ohms. Resistor 2, 10 ohms. Then we have a third resistor, resistor 3. Now the R sub n, that indicates that you can have an infinite number of resistors in a circuit. Most of the problems you're going to see are going to have 3, 4, maybe 5 tops as far as the number of resistors. This is a very representative example that I'm giving you. But once you have those numbers plugged in, then you're going to divide 1 by 15, 1 by 10, then 1 by 15. And let me bring the calculator to show you what I did here. I did round to 2 decimal places, and that, again, that's more than adequate for these types of problems. But 1 divided by 15, 0.067, I rounded it to 0.07. Then you have 1 divided by 15 again, same thing, 0.067, rounded to 0.07. Then 1 divided by 10 is 0.1. We really don't need the calculator for that. But once you have that mathematical operation complete, You can do this in slightly different order than what I'm doing it. But what I'm going to do, I'm going to take the 1 that's the numerator in the term to the left of the equal sign and make it the numerator on the right of the equal sign. All I did was slide the 1 over. And again, I'm not going to go into the mathematical mechanisms involved there, but that's in essence what you'll need to do. Again, our goal is to isolate our parallel for the total resistance in this parallel circuit. Then once you have this done, that mathematical operation, sliding the 1 in the numerator over here to the 1 in the numerator over here. And again, it's canceling out on the left, and it remains on the right of the equation. So now we need to add up the 0.07, the 0.1, and the 0.07. And when we do that, we end up with 0.24 in the denominator of the term to the right of the equal sign. Now the last iteration, all we need to do is divide 1 by 0.24. And 4.167, and I'm going to round that to 4.2. 4.2 ohms is the total resistance in the circuit diagrammed here on the slide. Total resistance, 4.2 ohms. All right, and that's it for calculating the total resistance in a parallel wired circuit. This again won't be a standalone problem that you'll see more than likely, but it'll be part of another problem, and we'll work one of those problems in subsequent tutorials. All right, if you have any questions, let me know, and I will see you in the next video.